Back, everyone. Evan is a passionate fifth-year computer science and math student and tutor at UNSW. When he's not thinking about security, informatics, or giving talks at conferences, you'll find him running the Security Society of New South Wales, nomming on Subway cookies or chasing bunny rabbits, or right now, breaking ads. Take it away, Evan.
Awesome. Thank you very much. Welcome, everyone, to my talk where I'll be hacking mobile ads. Cool. So quickly, who am I? I am a tutor at UNSW. I'm in my fifth year, and I've been doing security as a side thing ever since first year because it's just so much fun. And yeah, I'm also the president of the Security Society. So if you find this interesting, you'll probably find all of our other members interesting too. But enough of that. I have a confession, and that is that I don't like ads. And before you crucify me because ads are what make the world go round and so forth, I want to be specific and say that I don't like bad ads. Ads that are irrelevant, not interesting, and more importantly, deceiving. Like take this mobile website, for example. Not only do all of these ads have nothing to do with this recipe of Belgian waffles, but this is how much of the screen space they take up. And you can tell how frustrating this can be when you're just trying to like take in some content. But unlike the internet, ads on mobile games are also quite different. So for example, if we take this, here we just like have a game where you've reached the end of a level, and before you can proceed, you're given a video ad. In this case, it's a video about this blackjack iPhone game. And then you get about 5 seconds before you're allowed to skip, and then you can continue on. Or you can also have playable ads in games. So here's an example of that where there's a game where you can crash, and you can undo your crash by watching this ad. And in this case, this ad is actually a playable ad. And because it's an ad where you get a reward, it actually lasts for about 30 seconds, and you can't skip it. But what you can do is you can play it. So it kind of hints to you like that you can drag in blocks, and you just go chug along and see what you can do. But the reason this ad in particular is a bit frustrating is, as you just saw, it just boots you off to the App Store as soon as that time is up. That can be quite frustrating if you're playing this game and suddenly you're in the App Store being asked to download a different game. So why am I here ranting about these ads? Well, because there's like a lot of these frustrating ads, and they can be quite like mentally demotivating when you're going through a lot of them in like your daily life. But instead of me just like ranting about lots of bad ads, I think it'd be better if I show you an example of some good ads. So for example, we have this playable ad, which is a Bejeweled style game. So what you can do here is you match these emblems together, and the more you match, the more damage you do to this dragon. And there's also characters at the bottom which you can tap and deal more damage. But the things I want to point out is that nothing here is being forced. Nothing here is scripted in any way. You have full reign over how you can enjoy this ad. And because it's a game, you can interact with it however you want. And I think that's a very nice way of putting it. Like if you want to trial a game, this is a pretty good way of doing it. And as you saw at the end it just says like, congratulations, you've won the game. Maybe you want to download it and keep going, or you can go back to your original game. And I think it's a really nice way of doing it. But what you might be thinking now is, well, Evan, what are you doing? Why don't you just use an ad blocker? If you hate these ads so much, just block them entirely. But the thing is, I don't want to block these ads because if I block them, I won't get any rewards. Like in the last video you saw, on the left, there's a gift box. And as soon as you crash, you lose that gift box. You don't get to take it back unless you watch an ad, and as a reward, you can claim that gift box again. And If you were to just disable your internet connection or install an ad block, you'll get something like this instead, where you might crash a train, and then where there would be the option to let you play an ad to like undo your progress, instead there's nothing, and you can't go back from that. And if you're like playing a lot of these games and you want to make progress quicker and so forth, some of this is actually important. So what am I trying to do here? What am I trying to accomplish? Well, what I would like to do is, instead of having a normal ad, I'd like to just replace all the content. I'd like it to be a happy ad. I'd like it to, bring a smile to my day or something like that. But moreover, what I'd also like to try and do is, remove the links, change them so that like nothing ever happens, and like remove the timer. So instead of ads being 30 seconds long, they can just be like 1 second long, right? And then, or 0 seconds long, and then still have the same undo process happen. So all of this got me thinking, what are these ads really running? How do they really work? And like, can I change how they work? And how do I know that they're not just Bitcoin miners in disguise? Because sometimes I'm playing this and suddenly my phone gets really hot while I'm playing. It's like, well, what is this ad doing that I can now cook an egg with, right? Like something's not right. So like when you go on these kinds of like research excursions, you kind of need to set yourself a scope, right? Like what are you going to confine yourself to? So as you saw before, the two games I was playing was Skiing Yeti Mountain and Train Conductor World. And I picked these two games for a couple of reasons. First of them being that I just like these games. I think if you're going to spend hours and hours waiting for ads to appear while you're playing a game, it might as well be games that you enjoy. As a consequence, I finished these games. I don't think I would have liked to finish some other game I wasn't really interested in. Secondly, if I'm going to sit there watching ads and giving money to the creators, I'd rather give them to the games that I want to support. So like, I don't want to give more money to Candy Crush, for example, right? But like every time you watch an ad in Skiing Yeti Mountain or Train Conductor World, with the skiing game, the ads proceeds are going towards the Nepalese earthquake fund. And with Train Conductor World, that's actually made by the Voxel agents down in Melbourne. And I love their work, and I want to support like the Melbourne game industry as well. And the last thing is that both of these work using the Unity ad framework. So what I like, there are different things that I've tried, but I think it's much easier when you start with to confine yourself to one specific field, not playing around with lots of different things. You can try like 2 different games using the same framework, and you don't have to change a lot of things around. And that was really helpful. And lastly, I want to make sure that the scope that I'm dealing with is specifically to the local network. I don't want to have to worry about hacking my phone, or like reverse engineering the games, or like hacking the web servers that these games are running on, or anything like that. I just want to keep it minimal in that sense. So like, how does this all work? So normally your phone would connect to the internet as normal. But what we want to do is we want to be this person in the middle. And what we want to do is we want to reroute the traffic that goes from the phone to us and then back to the internet. We will relay that information back to the internet. And so like, how do we do this? Well, there's a thing called MITM proxy, which stands for man in the middle proxy. And essentially we're being this man in the middle. And this proxy is great. It's open source. It's written in Python. So it's quite simple to use and set up. So basically all we do is we install the proxy on one of our computers, and we configure the phone to use it, and then we're good to go. But we have a problem, and that is that everything is encrypted, right? Because everything uses HTTPS now. And the way HTTPS works is that your browser comes with like these certificates that your browser implicitly trusts. And then you use those certificates to sign some other certificates, such as the ones that the server gives you. So if you're trying to connect to a server, the server, like Google, like your server would give you certificates, and those are checked against the ones you have. And then you use the certificates to exchange keys for encryption. And then now you and the server can use this shared secret key to encrypt the data. And of course, like this encryption thing is a big no-no. Like we don't want encryption in security, especially in this circumstance where what I want to do is I want to read and intercept and like change the data that's being sent between the phone and the internet. Like before the data goes back to the internet, I want to manipulate it before sending it back. So what MIT and Proxy lets you do is install your own certificates. So essentially, you install a certificate that from MIT and Proxy, and now when you try to connect, instead of using the website's certificate, you use the certificate you generated. So essentially, what you're doing is you're hacking yourself. I should probably remove that certificate now after this talk, but we can continue along. And now you can read everything, and then before you send it off to the internet, you re-encrypt it with the original certificate that it would have been encrypted with, more or less. Finally, you put all of this on Raspberry Pi and you just chuck it at the back of the room and you forget about it, and you just want to make it simple so that you can do your testing easily. Essentially, I just had it set up so that I could do it wherever I have Wi-Fi connection. I should say that like none of this was easy. There was a bit of setup involved, and there was a lot of research to be done on how this should be set up and so forth. But I did manage to get it done in the end. So I think if I can do it, you can definitely do it as well. But what do we do now? Well, we've set it up. What we want to do is actually like do our research. We want to like cast the net out and catch these requests. And it's quite strange to be writing a talk by playing games and just waiting for ads to appear. But trust me, at the end, you do really get sick of it. But as an example, this is MITM. This is the web proxy interface. And on the left, you have all the requests that have come through. And on the top right, you've seen that I've highlighted all the GET requests are videos. That like the responses are videos. And essentially what I'm trying to do is trying to filter out and find all the requests that all the video ads that are being sent to my phone, because that's just somewhere I want to start. And then after some while, you also manage to catch some playable ad requests. So in this case, we have a playable ad, and all it is just a request to a web page. And this is that request here, and we can actually click on this link now. So bear with me for a moment while I do that. Okay, awesome, cool. So you can see this is just a normal game. It's quite slow because it's not meant to be running on a computer. It's meant to be running on a tiny phone screen. But what we want to do is take a look at the index. This might take a bit to run. You'll see why in a moment. If it doesn't, let me refresh. Okay, cool. So you'll see it's just some basic HTML with some meta tags and so forth. At the bottom, we have this script that runs some other JavaScript, which is in here. And Chrome nicely asks us to pretty print this, so we'll do that. If we wait a second or so, it's expanded it out to about 30,000 lines of JavaScript. Now, I'm not going to sit here and say that I've read every single line of JavaScript and I like vouch for it and it's great. I don't have that level of JavaScript to be able to like say that. But from a higher level, there are some assumptions you can make. If you just skim through it, you can see that it is minified, and it does look like it's generated code from probably like the Unity app engine They've written their game there, and then they've just ported it over using some function. And it doesn't seem to be doing anything intensive like Bitcoin mining. But that link is there, so you can go there and test it out if you wish. But let's move back. Cool. Let me just fix this for a moment. Okay. Cool. Awesome. So let's get back to what we were doing. So the phone is sending a request for content through us, and then we're relaying that content to we're relaying that request to the internet. And then once we get it back, we send it back to the phone. But what we want to do is when the phone requests us for content, we then throw that content away. We don't care about it. We don't send it to the internet. What we do instead is we send our own malicious content back to the phone. One of the nice things about MITM proxy is that you can do this. You can write a function that every time a request comes in, you can change its insides, right? So in this case, we're saying if the request is a video ad get request, and be told the video slides are bad. I hope that's better. Okay, so awesome, cool. Awesome. Okay, so essentially we just check if it's a video ad request, and if it is, we take its content and we replace it with the content of our own video file. And then this is what we get. We just get a black screen. It didn't work. And some of you might be sitting there and thinking, well, Evan, of course it didn't work. Like requests are a complex thing. You can't just replace the content and expect it to work. Like there's headers in requests, and you got to look at the length, and you got to change that accordingly. And maybe the timestamp is off, and it checks that, or maybe the request has some checksums using hashing, or maybe it's encrypted and so forth. And you may be right. And I did try all those things, but nothing seemed to work. So I needed to take a step back and branch off and try something else, get out of the rabbit hole and to go deeper somewhere else. So I went back to all the requests that were being made, and I investigated what else could I look at? And I noticed that in particular, this auction URL contained some of the files, links to some of the further requests that were being made. And I thought, okay, well, maybe I can mess around with that, which kind of makes sense, because if you don't know, the way ads work is companies bid in an auction for their ads to show up over other companies. So I looked inside the content for this request, and what it does is it makes a request with some JSON, and it says, well, there are a couple of video ads I want to make. One of them might be free coins. One of them might be undoing a crash like you saw before. And you can also choose whether you want to be able to skip the ad or not, and whether it's a video ad or MRAID, which stands for Mobile Rich Media Ad Interface Definitions. You can Google that, but essentially it's just a playable ad. I have no idea what display is, but let's move on. The response that we get back from that is another JSON payload. So we can take a look at that, and you can see there's some info, but what we want to look at is this content. That's another JSON payload as a string, which is strange. But inside that string is this, and you might look at it and say, oh, some of this is interesting. For one, we've got the game name, which is soap cutting. We've got to love soap cutting, and the rating and so forth. And we can change that, but it's probably not so interesting. What we probably want to change is the game icon. So the icon that's displayed as part of the game, or the end screen icon, or the images, right? And because these are just simple, what was that beep? Oh, strange. Because these are just simple URLs, we can just change it as is. So that's exactly what I did. I hosted some content and I changed it. And this is what I got. this is a cube collecting game where you can choose the size of the scoop, but you can see the icon on the left has turned red, and I've put my own like image where like the normal ad should be. So like success, right? Like we've managed to change something, which is awesome. But what we want to do is change the video, right? So let's try and do that. We've got the video URLs there as well. So I change them. And again, I get this black screen. And, you know, we have the same problem as before because there's this like extra data that we need to consider. But, you know, like let's try it and see what happens. So in this case, we've got like try blank today, which is just a video that I put, a picture that I put through FFmpeg to make it a video. And yeah, you might have noticed that I've also reduced the time of that video to just 5 seconds, which is great. But awesome. Like let's go back for a minute though, because what we want to do is look at playable ads. And eventually a playable ad comes through, and we notice that through this mraid URL in the content. And here it is again. And, you know, we can change that as well to whatever URL we want. So what I decided to do is just change it to be Hacker News. So now I can read the news as an ad, and it just works like a normal browser, more or less. But it is a bit slow because it's not meant to be like viewing news. It's meant to be playing games, which is a bit strange. But you can click through the links. There is one issue though, which is that you can't scroll or anything like that. Maybe through the power of JavaScript, you could achieve that. But even if I try to like do the iPhone method of selecting text and dragging it down, it just doesn't make a difference. But it is something you can explore. Cool. So like what now? What can you do with all this? Well, you can change the length of the ads. You can change the content that it's being given. You can make your own requests for ads. You can do a lot of stuff. Theoretically, you could even like install a certificate on your phone and a server, and then run a DNS client that forwards these requests to the server and resolves them as you wish. But I think the main thing to keep in mind is that to achieve this, you have to really have this whole thing set up and like and hack yourself, right? So it's not really something that you can like make as an app and have people download it, because it wouldn't be a safe thing to do. Like you need a lot of trust for the users that you're having. So there is that to keep in mind. Yeah, and like even though I've done this for quite a while, it's not something I've just have set up the whole time either, because it just takes, you know, like there's other things that having a proxy in the middle of all your requests actually blocks. But yeah, that's about it. Thank you for listening. I'm happy to take questions if there's time, or you can talk to me in Venuless. Awesome.
Thank you so much for that. I think a lot of people are blissfully unaware of how advertising works, so I think this was a nice intro to it.
Awesome, yes.
We're about to go into a break, so probably answering questions in Venuless is going to be the easiest way. But cool. Again, thank you so much for your wonderful talk.
No worries. Thank you so much for hosting.
Always. We're so keen to have more new speakers around.
Awesome. Thank you.
We'll be returning at 2:30 conference time and 3 p.m. Australian Eastern Time for our next talk, All Hands on Deck, Handling Security Incidents.